Okay, now let's talk about speed. Speed is a scalar quantity, which means that it does not include direction. So, like distance, we don't care if you're going forwards or backwards, left or right, up or down, east or west, north or south when we're talking about speed. Speed does not include direction. The definition of speed is simply the distance an object travels. This object can be a person, it could be a thing. It's the distance the object travels in a unit of time, or in an in an amount of time. Okay, so how far do you go in how much time? To calculate this, we use the formula speed equals distance over change in time, where S is speed, D is distance, and delta T, or triangle T, is change in time. When you look at this formula, you should be able to tell that the units you'll end up with are some sort of distance unit, like meters, kilometers, miles, over some sort of time unit, seconds, minutes, hours. So we're going to get meters per second, or kilometers per minute, or miles per hour, or kilometers per hour, or meters per minute. Okay? These are just some examples of the kinds of units we'll end up with. Let's look at some example problems to work. Here's one. A car travels 50 kilometers in half an hour. What is its speed? So the first thing I'm going to do is write my formula. Speed equals distance divided by time. Then I'm going to write what I'm given. I don't know my speed, but I do know my distance is 50 kilometers. And I do know that my time is half an hour. Now I just need to plug in. Speed equals 50 kilometers divided by 0.5 hours. Get my calculator. 50 kilometers divided by 0.5 gives me 100. So my speed is equal to 100 kilometers per hour. Okay, I look at what I'm given. 50 has 1 sig fig. 0.5 has 1 sig fig. So my answer should have 1 sig fig, which it does. Let's look at this one. A person runs 3 kilometers in 35 minutes. Again, my formula is speed equals distance over time. I don't know my speed, but I do know that my distance is 3 kilometers and my time is 35 minutes. So I can plug in speed equals 3 kilometers over 35 minutes. Grab my calculator. 3 divided by 35 gives me, my calculator answer would be 0.085714 kilometers per minute. When I look, I've got 1 sig fig here, 2 sig figs here. So that means I need just 1 sig fig in my answer. So my answer in sig figs would be 0.09 kilometers per minute. Let's look at this one. A dog walks for 10 meters per minute for 5 minutes. How far did he go? So here I know I'm going to be looking for distance, right? Let's look at my formula. Speed equals distance over change in time. My speed I know is 10 meters per minute. My distance, I don't know that this time, but I do know my change in time is 5 minutes. So I can plug in 10 meters per minute equals some distance that I don't know over 5 minutes. If you put this over 1, you can cross multiply, or you can solve the equation using algebra. Either way, you'll end up with 5 minutes times 10 meters per minute gives me my distance, right? If I cross multiply, that's what I get. Or if I solve by algebra by multiplying 5 minutes on both sides, this is what I get. My minutes are going to cancel out, leaving me with 50. 5 times 10 is 50 meters as my distance. I need 1 sig fig and 1 sig fig, and I have 1 sig fig, so I'm good. Let's look at this one. A ball rolls 5 meters per minute. How long did it take the ball to roll 3 meters? So again, I'm using the same formula. My speed is 5 meters per minute. My distance is 3 meters. This time I do not know the change in time. I don't know how long it takes, right? So I can plug in 5 meters per minute equals 3 meters over change in time. I don't know that. I can cross multiply or solve by algebra, and I'll get change in time equals 5 meters per minute. Change in time times 5 meters per minute equals 3 meters. I need to get change in time by itself, so I'm going to divide by 5 meters per minute on both sides. And I'll get these to cancel out. I'm going to grab my calculator and say 3 divided by 5 is 0.6. So here I've gotten change in time is equal to 0.6. My meters cancel, minutes. When I look back at my problem, I've got 1 sig fig and 1 sig fig. So I need 1 sig fig in my answer, which is what I have. Okay, so my change in time is 0.6 minutes. One more example. A child rides her tricycle for 10 meters per minute. For 20 minutes. How far did she go? My formula is the same. I know my speed is 10 meters per minute. My distance, I don't know, that's what I'm asked for, right? And how far? My change in time is 20 minutes. So I'm going to plug in 10 meters per minute equals distance, I don't know, over 20 minutes. I can cross multiply or solve by algebra. Either way, I get 20 minutes equals times 10 meters per minute equals distance. My minutes cancel out, so I get 200. 20 times 10 meters equals distance. When I look over here at what I was given, I have 1 sig fig and 1 sig fig, so my answer should have 1 sig fig, which it does. Okay? If any of these are confusing to you, be sure you write down a question so that we can answer it in class tomorrow. Or go back and watch again how I solved the one that's confusing, if just one is confusing. Okay, but we'll go over these again tomorrow, and I'll answer any questions that you have if you will remember to ask them. So write them down so that you will remember. Okay, there are 2 types of speed. There's average speed. This is the total distance over total time. Right? So on your way to school, you might have to speed up and slow down and stop for stoplights or stop signs or for traffic, right? All that time is included and all the distance you travel is included. That's the average speed. Your instantaneous speed is your speed at a given moment or second. Okay? This is what your what cops clock. When cops write you a ticket, when the police write you a ticket, they're writing you a ticket based on your instantaneous speed. The speed right then. They don't really care if you went slower a while ago and it would average out. They're giving you a ticket on that instantaneous speed. This is what your speedometer on your car reads. The speedometer is that little needle where you've got like 10, 30, 50. I know it goes up higher than that, but it would be too crowded. And your speed is being read by that little needle. Okay, this is the speedometer. That's what the speedometer is reading. It's telling you your instantaneous speed.